Today we're going to be talking about circuit bending. First, I'll give you the lowdown. In 1967, just about, Reed Ghazala, a man who is from Cincinnati, Ohio, had a toy organ that was pocket-sized, and what happened is the open circuitry was in a desk, and it slid and made a lot of very strange noises. And through that concept, he randomly took components of electronics and opened up them and rewired them to sound very strange and disoriented with really no concept or purpose, just for the expression of noise. So what we have here today is I took apart this thing called a sound machine. It has, about 16 noise samples like this. And what we're going to do today is we're going to look at what components are going on. Now, this is a very simple circuit, and it's low voltage. It's important. This is only, it looks like 6.5 volts. It looks like. So that is what's going on here. This speaker is a 16 ohm watt at half a watt, and right here we see the circuit pattern. So this is the main membrane. This is called like the epoxy chip. That's basically a little microprocessor inside of that, and it has all these routes of all the different components and such. Here's one strategy and method of messing up the sound. So this right here, it seems that this is the clock resistor, like right there. So those things, and you lick your finger, play the sample, and depending on how much saliva that you have, you can alter the sound. And then from that point, let's see if we can make any more noises happen. So I'm going to do the capacitor. This is a pretty modern piece. Crazy. If you get stuff from like the early 90s or the mid 80s, when like the circuit components are like more out, like if you see like an actual resistor. But what happened is this guy, in China they have all these things. They make these boards, and you see how these resistors and capacitors are very small. They're like very small solder points and stuff, so that it can be cheaply made and such like that. That is circuit bending in a very, very, very simple context.